आज इस वीडियो में हम EKUEB क्लास 10th एग्जामिनेशन में 2016 का पेपर 1 सॉल्व करेंगे. सो लेट्स सी क्वेश्चन नंबर 1 व्हाट वी हैव इन दिस क्वेश्चन. So in this question we have to simplify this expression, and this expression we have is x plus y into x minus y divided by x minus y whole square. So let's simplify this expression, x minus y and x plus y divided by x minus y whole square. So without any further factorization, we can cancel out this x minus y with this x minus y. So we will have the remaining as x plus y divided by x minus y. So the correct answer we have is option D. So let's see question number 2. And in question number 2, we have to find the HCF of these two terms. So one expression is already factorized and the other one x square plus 2x plus 1. As we can see, it is a perfect square of x square plus 2x into 1 plus 1 square. So the factorization of this expression would be x plus 1 whole square, that would be equal to x plus 1 and x plus 1. So the factors we have for these two expressions are x plus 1, x plus 1 and x plus 2. So as we can see, there is no factor common between them. So whenever there is no factor that is common, so there is one that is always the common factor among all expression. So the correct answer we have for this question number 2 is option B, 1. Next, we have to find the square root of this expression, and for taking square root, let's make the factor of this first expression. So as we can see, this is already a perfect square where a square plus 2ab plus b square. So a and b is 2. So we have the perfect square as a plus 2 whole square, and the other factor that was given was a plus 2 whole square. If we take the square root of this expression, this square and root would be cancelled out, and we will get a plus 2 and a plus 2. So as we have taken the square root, we will take positive as well as negative. So the correct answer for question number 3 is option C. Let's come to the question number 4. And in this question, we have to actually break this expression, this rational expression, into its partial fraction. So as we can see, in this we have a repeated factor and one is the non-repeated factor. So for the repeated factor, the partial fraction is such that 3x plus 7 and 3x plus 2 whole square. So this is the repeated factor and this is the linear factor. So linear factor would be as it is 3x plus 7, and the repeated factors will be break with two constants like b over 3x plus 2 with power 1 and c over 3x plus 2 power 2. So this is the correct representation of the partial fraction of this of our given rational expression. So these option A and B are incorrect because we have only two constants. Similarly, we have question option C and D, in which we have the correct partial fraction of these expression. So option C we have is the correct answer, in which a over x plus 2, 3x plus 2, b over 3x plus 2 whole square, and c over 3x plus 7. So this is also the incorrect partial fraction of this question. Let's see question number 5. And in question number 5, we have to find the solution set of this expression ax minus a over a is equal to 0. So let's find the value of x. This a will be multiplied on the other side. We will have ax minus a equals to 0. This a would be moved to the right hand side and become positive. So ax will be equal to a and x will be equal to a over a. A and a will be cancelled out, so we will get only 1. So the correct answer for question number 5 is option B. Let's see the other question, that is question number 6. And in question number 6, we have to again find the solution set. X minus 1 over 4 is equal to 3 over 4. So we will shift this 1 over 4 to the right hand side of the equation. So x will become 3 over 4 plus 1 over 4. So as we can see, denominator of these two fractions are same. So denominator would remain same, while in numerator we will have 3 plus 1. That would become 4 over 4 and equals to 1. So the correct option we have for this question is option A. Let's see question number 7. And in question number 7, we have to find the solution set of this question. And for this question, if x belongs to real number. So as we can see, uh, there is a square root on the left hand side. So square root of any number cannot be can be positive or negative as well. So let's take a square on the both side of the equation. So we will get x plus 1 equals to minus 2 square. So x plus 1 would be equals to minus 2 square is plus 4, and x would be equals to 4 minus 1. 4 minus 1 is 3, so we have x is equals to 3. So let's check this x equals to 3 if this satisfy our given equation. So if we put 3 plus 1 equals to minus 2, and 3 plus 1 is 4, and square root of 4 is equals to plus 2, it not equals to minus 2. So this equation do not satisfy our solution. This our solution do not satisfy our equation. So this means the correct option for this question number 7 would be equals to A. That is the empty set. Question number 8. The solution set of this modulus equation x plus 1 modulus equals to 1. So let's expand this modulus. This modulus will be expanded in such a way that x plus 1 equals to plus 1 and x plus 1 is equals to minus 1. So if we find the solution from this expression, x plus 1 would be equal to 1 minus 1 and x would be equal to minus 1 minus 1. So from here x is equals to 0 and x is equals to minus 2 from this equation. So the correct answer we have is option D, that is 0 comma minus 2. So let's see question number 9 then. In question number 9, we have to find the point. We have to find whether this point is represented by which of these following point A, B, C, and D. So the value, first value, that is abscissa is x, and the second value minus 4 is the ordinate. It's mean we have x is positive and y is negative. In the first quadrant, x and y both are positive. In second quadrant, this is the first quadrant, this is our second quadrant, and this quadrant x is negative while y is positive. In the third quadrant, x is negative while y is also negative, and in last fourth quadrant the value of x is positive and y is negative. So we have correct option, that is option D. Let's come to question number 10. and we have to find that which equation satisfy this point 1 comma minus 2. So we have to put these value of x is 1 and y is minus 2. So let's take the first equation, y is equals to 3x plus 1. Put the value of y as minus 2 and for value of x put 1. So 3 plus 1 is not equals to minus 2. It's mean option A is incorrect. Then let's take second equation, y is equals to minus 3x plus 1. Y is minus 2, and for the value of x let's put 1. So minus 2 would be equals to minus 3 plus 1, and minus 2 would be equals to minus 2. So this point actually satisfy the second equation. It's mean the second option is correct for question number 10. Next, we have question number 11. Which of the following is the correct representation of this equation? So, this equation says that minus y is equal to x. So, this is the type of equation in which that passes through the origin, because at x is equals to 0, the value of y would also be 0. So, this equation is passing through origin. So, option D, C and option D would be incorrect, because when we put the values of uh, x0, y0, these lines are not passing through the origin. Similarly, let's say if we put x is equals to 1, y would be equals to minus 1. If we put x is equals to 2, y would be equals to minus 2. So for the positive values of x, the values of y should be negative. So here we have the correct answer, that is the in this option B, the values of positive values of x, these are the positive value. So for this positive value of x, we have the negative value of y. For this value of x, we have the negative value of y. And for negative values of x, we have the positive values of y. So this equation is correctly defined or represented by the graph that is drawn in option B. In option A graph, this is also passing through the origin, but this graph shows that the positive values of x will give positive values of y, and for negative values of x, we will have negative values of y that do not satisfy our given equation. So finally, the option B is the correct answer. Next, we have Next, we have question number 12. And in question number 12, we have to represent this equation in quadratic form. So we have 2x over x square minus 4 equals to 1. Let's multiply this expression to the right side. So 2x will be equal to 1 multiplied by x square minus 4. So 1 will be multiplied with the 1. So 2x is equals to x square minus 4. This plus 2x would move to the right side of the equation. That would become minus 2x. So x square minus 2x minus 4 is the correct equation for this given question. So option B we have is the correct answer, that is x square minus 2x minus 4 equal to 0. Next, we have to find the solution set of this quadratic equation x square plus x equals to 0. The standard form of the quadratic equation is ax square plus bx plus c is equals to 0. And in this given quadratic equation, the value of c is 0. So we can take x from that common. So we will have x plus 1 equals to 0. So for two values of x, x1x is equals to 0 and the other factor x plus 1 is equal to 0. So from these equations, we will get two values of x, that is 0 and minus 1. So for question number 13, the correct answer is option D. So let's move to the other question, that is question number 14. Question number 14, we have to find that what terms should be added to make this expression a perfect square. So let's try to make this a perfect square. X square minus 2x plus 3 over 4. So let's try to add these expression. Option A, if we add 3 over 4, so we will get the equation x square minus 2x plus 6 over 4, and 6 over 4 would become 3 over 2. So this expression would not still be a perfect square. It's mean option A is incorrect. Let's check option 2. In this equation, let's add the option B, that is 1 over 4. If we add 1 over 4, we will get x square minus 2x plus 4 over 4, and x square minus 2x plus 1 would be the remaining answer. So let's check if this is the perfect square. X square and 1 square, and in the middle term we have minus 2a and b. So uh, if we can check the middle term, this has become the perfect square x minus 1 whole square. So this is the correct option, that if we add 1 over 4 in our given equation, so we will get the perfect square. So question number 14, the correct answer is option B. Let's come to question number 15, and in this question we have to find the distance between these 2 points. So let's say this is x1 and this is y1, this is x2 and this is y2. The formula of distance between 2 points is x2 minus x1 whole square plus y2 minus y1 whole square. X2 minus x1 would become d minus d whole square plus y2 minus y1 is minus d whole square. So the first bracket would become 0, and minus d would become minus 2d square and square root. So if we take the square, we will get 4d square, and if we take the square root, we will get 2d. The distance between these two point is 2d. So the correct answer we have is option D. In question number 16, if a circle has a center this and the radius of the circle is 2 centimeters. So let's take the circle, and the origin of the circle is 0 comma 0, and the radius of the circle is 2 centimeters. So let's mark this point, and we have the radius 2 centimeter. We have to find the distance between the ends point of the diameter. So diameter is actually double of the radius. So if radius is 2 centimeter, so our diameter would be equals to 4 centimeter. So correct answer for this question number 16 is 4 centimeters. Let's see question number 17. What we have in this question. So 3 points are given in this diagram that are collinear points, and the collinear points means that these point will lie in a straight line. So for the collinear point, the sum of this distance and this distance would be equal to the distance AC. This distance is AB, this is BC, and this distance is AC. So the sum of AB plus BC would be equal to AC. So the correct answer for this question is option B, that distance between point AC is equal to distance between point AB and BC. So next we have question number 18, and we have to convert this system into degree and minutes. So question number 18, we have 90 minutes, and we know that 90 minutes, let's split into 60 minutes and 30 minutes. So we know that 1 degree is equal to 60 minutes. So the 60 minutes will become 1 degree, and plus we have 30 minutes. So this can be represented like 1 degree, 30 minutes and 0 seconds. So the correct option we have is option A. Next, we have question number 19, and in this question, we have the arc length of 10.5 centimeters. So, this is represented by L, and the frontal angle, that is a measure of 1.5 radians. So, this is theta, and we have to find the radius of the circle. So, the relation between them is L equals to R theta. So, R will be equals to L over theta. So, arc length is equal to 10 0.5 centimeter and theta is 1.5. So if we divide the 10.5 by 1.5, so we will get equals to 7 centimeters. So the for question number 19, the correct option is option C. So let's move to the next question, that is question number 20 and 21. So for question number 20, we have to simplify this expression in which we have sine square theta multiplied by cosec theta. We know that cosec theta is equal to 1 over sine theta. So sine square and sine theta would be cancel out with each other, and we will get sine theta as the result. So for question 20, we have the correct option, that is option B, sine theta. Let's see question number 21, and in this question we have a right angle triangle PQR, and we have to find the value of sine square theta. The value of sine is perpendicular over hypotenuse, and perpendicular, we know that the side opposite to the angle is perpendicular, while the side opposite to 90 degree is hypotenuse. So perpendicular would be P and hypotenuse will be R. So the sine square will be equal to P square over R square. So 21, the correct answer is option B. So let's see question number 22, and in this question we have to find that which will not form a right angle triangle. So for right angle triangle, we can apply the Pythagoras theorem, h square equals to p square plus b square. So we know that the greatest side is the hypotenuse. So let's check this option if this is hypotenuse, and the remaining would be perpendicular and base. So 10 square should be equal to 5 square plus 5 square. 10 square is 100, while 5 square would be 25 plus 25. So this both equations, the sides of the equations are not equal. It means this will not form a right angle triangle. For remaining three options, we can satisfy this Pythagoras theorem with these values 3, 4, 10, 3 root 2, 4 root 2, and 5 root 2, and 6, 8, and 10. These all can be the side of a right angle triangle except option D. Let's see question number 23. In this question, if we have a right angle triangle of base 9 centimeter and having a perpendicular of 40 centimeter, we have to find the hypotenuse of the triangle. So according to the Pythagoras theorem, hypotenuse square is equals to perpendicular square plus base square. Hypotenuse square is equals to perpendicular is 40 square, and base will be equal to 9 square. So 40 square will become 1600, and 9 square would become 81. So if we add these two terms, we will get 1681, that is equal to h square. So if we take the square root on the both side, the value of h would become 1681, and we have to take the square root of this 1681. So we will get A equals to 41. So the correct option for this question number 23 is option A. Let's see question number 24. In this question, if a right angle triangle hypotenuse is 9 and the perpendicular is 5 centimeter. Again, we have to find the base of the triangle. So again, we can apply the same theorem, h square is equals to p square plus base square. Hypotenuse is 9 and base is we have to calculate, and perpendicular is 5 square. So 9 square would be 81 and 5 square would be 25. So if you subtract these two terms, so b square is 56 and b would be e base would be equal to square root of 56, that is equals to 2 square root of 14. So the correct option in question number 24 is option B, 2 root 14. Let's see question number 25 and 26. In question number 25, two chords in a circle, each of them having the length of 5 centimeters. So, two chords in the same circle are equal 5 centimeter and 5 centimeter. So two chords are equal, then we have the distance from their center is also equal, and the length of major arcs, length of minor arcs, these all are equal. So if one chord is at a distance of 7 centimeter from the circle, so we have to find the distance of the other chord from the center of the circle. So this is simple theorem says that if two chords are equal, then they should be equidistant from the center of the circle. So the correct option is option C, 7 centimeters. In question number 26, if a straight line is drawn from the center of the circle and it bisects the chord. So for example, we have a circle, we have a center, and we have a chord. A straight line drawn from the center of the circle and it bisects a chord. So let's say this is the line. This line passes through the chord as well as the center of the circle, and it is making dividing this chord into two equal parts. So we have to find the angle between the line and the chord. So we have studied in our theorem that whenever a line passing through the center as well as it bisect the chord, so it will always be perpendicular to the chord. So the angle between that line and the chord would always be 90 degrees. Let's see question number 27. And in question number 27, we have two circles that are touching internally. And what we are given, if the diameter of the circle A is 24, we are given with diameter of A 24, it's mean 12 centimeter would be its radius, and diameter of we have the distance AB. We have the distance between their centers, and we have to find the radius of the circle B. So let's say the radius of this greater circle is R and the smaller circle is R. So according to our theorem, if two circles touches internally, the distance between their center is equal to difference of their radius. So radius of the greater circle is 24 and the smaller one is we have to find out, and the distance between them is 9. So 9 will be equals to 12 minus r. So r would be equals to 12 minus 9. So value of r would be equals to 3. So question number 27, the correct option is option A. So quickly let's move to our question number 28. And in this question, we have a circle in which the central angle are given x, y, and one is unknown, and the minor arc formed by these two radii are given in which these two minor arcs are equal. So according to theorem, if two arcs are equal, then the angle between them would also be equal. The central angle is equal, this minor arc will be equal, arc length will be equal, and the chord formed with these 2 points would also be equal. So missing angle here we have, it will be equal to x. So question number 28, correct option we have got is option A. So let's see question number 29. And in this question, we have a cyclic quadrilateral in which all the points of this quadrilateral lie on this circle. So the theorem states that for a cyclic quadrilateral, the opposite angles are always supplementary. So these two angles will be supplementary. So x plus 130 would be equals to 180. So the value of x would be equal to 50 degree, x equals to 50 degree. So the correct option we have is option A, that is 50 degrees. Let's come to the last question of this year, question number 30. And in this question, we have a circle and a diameter AB. And we have to find the sum of angle C and angle D. So here we have the angle C and angle D in this diagram. And if I can see this ABCD is a cyclic quadrilateral, this means that the sum of the opposite angle is always 180 degrees. The opposite angles of a cyclic quadrilateral inscribed in a circle is always 180 degree. They are supplementary. It's mean angle C and angle D are the opposite angles of a cyclic quadrilateral in a circle. So the sum of them will be equals to 180 degrees. So for question number 30, we have the correct option, that is option D, 180 degrees.